Hello, sixth graders. Welcome to class. It is good to see you. For today's math, we are going to practice how to find the distance between 2 points on a graph. We're going to find the distance between 2 points on a coordinate grid. All right, let's do a warm-up. How far apart are these two dots? Right here and right here. How far apart are those? Excellent. They are just 1 unit, one jump apart. That's how far apart they are. Okay, now let's do a different one. How about this? How far apart are these 2 points on the coordinate grid? Que excelente! Yes, they are 4 apart, 4 units apart. 1, 2, 3, 4. They are 4 units apart. Good. Ooh, you're getting good at this. Okay. How about this and this down here? How far apart are these 2 points? What is the distance between these 2 points on the graph? Absolutely. It is 11. Not negative 11, not positive 1, but it is 11 units. They are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 units. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 units. 11 jumps. Wait, Mr. Bertram, how come there's not a negative? It goes down into the negatives. How come it's not a negative answer, even at all? Why do you think that was so silly? Distance is never negative. When you or when your parents pull up Google Maps or Apple Maps and they try to see how far is it to the store, Google Maps is never going to tell you a negative distance. Go -5 kilometers to the south. That's now just say go 5 kilometers to the south. No such thing as a negative distance. So for today's homework, tomorrow's homework, for this math, any math about distance, the answer's can it be always positive? The answer is always positive because distance is a real world math that is always, always, always positive. 11 units. Now let me put all these dots back up here on our screen. All the pairs that we talked about. What do you notice about these pairs of dots? Do they have anything in common, these 3 pairs? Hey, those are some good things that they have in common. Maybe you said it, maybe you thought it. But my favorite thing of what you said slash thought of what they had in common is that they all have the same x value. If you recall from our previous lessons, every point on the coordinate grid has directions. They have an ordered pair that says where that point is on the coordinate grid. And you write this pair like this. First it's the x value, then it's the y value. So for this dot, we have 3, comma, 4. Go over 3, up 4. This dot, we go over 3 and up 3. 3, comma, 3. Here we go over 5, up 4. So it's over 5, up 4. Here we go over 5, up 0. So it's over 5, up 0. Here we go over to -4, over to -4, and up to +6. And what's this last one? What do you think it is? Drop it in the chat. Awesome. It's over to -4, and then down to -5. That is the ordered pair for this one. All of these pairs of ordered pairs, these pairs of points, have the same x value. These have the same first number. These have the same first number. These have the same first number. For today's math, you are going to find the distance between two points on a graph that have the same x value. Sometimes you can count, just like this, just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, done. But what if we have something a little more challenging? Like, what if instead of whole numbers, what if instead of integers for our points, we have decimals. Uh-oh. Like this. How far apart are those? That's going to be hard to count, so let's write the ordered pairs down. So we go over to 2, so that's our first number, and then we went up to 2.8 or 1.8. 1.8. Here, we went over to 2, and then we went down to -3.5. Well, shoot. What's the distance between these points? Now, I mean, can you still count? Is there a formula you could use to help you find the distance between these and any point? That is an interesting question indeed. That's going to be part of your challenge today. It does tell you in the homework walkthrough video. So if you spend our exploration time struggling with this question, this interesting question of how do I find the distance between 2 points that I can't just count, you can always go watch the homework walkthrough video on your homework, on your independent practice. So we have practiced together, we have watched, we have learned. Now let's talk about our VR activity. In VR, you will have 4 or 5 different pairs of points, pairs of ordered pairs that have the same x value. And you will need to find the distance between those ordered pairs. You will have some tools to help you. This is a very special lesson because we're going to the Mount Olympus location, and there are some ginormous coordinate grids, graphing whiteboards there. Mr. Bertram, how are we going to use the whiteboards to help us if they are so humongous? Please tell us. You will have the opportunity to practice the new VR skill of flying, either with a drone or a ferry, up to the whiteboard, the giant whiteboard. And you can use that giant whiteboard to help you find the distance between the points, the distance between the ordered pairs that are in your groups. You don't have to fly. And if you abuse your flying powers, your awesome sub might just delete the drones and ferries. So make sure you don't abuse them. And because you can also just look at the coordinate grid too and count. Or your sub can load in the coordinate grid whiteboard too. But we want to practice the drones. We want to practice the ferries so we can get super good at them. So fly on up to the giant whiteboard. See, maybe mark on the whiteboard with your 3D pen where these different dots are. Practice those plotting skills. Practice those distance finding skills between 2 points. Oh, how exciting. Okay, enough of me talking. I want to see you hop into VR and get started. So I will see you tomorrow. Bye, 6th graders.